Now we are going to calculate the equation of motion for the compound pendulum, and this is the original position or the equilibrium position, and then the rigid body moved towards this angle. So this is the center of gravity, and now this is the center of gravity. The distance is h. The weight mg is acting downwards, and again this is having two components. This is angle theta, then this is theta. The restoring force is mg sine theta. Since this is a torque or the angular equivalent, instead of mass into acceleration, the rotational log of mass is I, then the rotational log of acceleration is the angular acceleration, that is I into d square theta by dt square. That is this is acceleration, and that is equal to moment of force or the couple. Here it is the couple, and for that this is a restoring force, therefore minus mg sine theta. Then the perpendicular distance from the axis of rotation, that is the distance between this center of suspension and the center of gravity, that is h. And now we can rearrange the equation. That is I d square theta by dt square plus mg sine theta h is equal to 0. Again we are restricting theta to be small, that is sine theta is approximately theta, that is d square theta by dt square plus mg theta by I h is equal to 0. And comparing with simple harmonic motion, this is omega square. Omega square is mgh by I, and omega is root of mgh by I. T is 2 pi by omega, that is t is equal to 2 pi into root of I by mgh, and this is a time period. And we can write this in another form also, 2 pi into root of I by mgh. This moment of inertia is about this axis. This I is about this axis, and we know the moment of inertia about this axis can be written with the help of the parallel axis theorem. This is a parallel axis, and then this distance is h, and so that we can write I as Ig, that is a parallel axis with respect to this I axis, plus mass into distance between the axes is h, the square of the distance. And this is parallel axis theorem. These are the two parallel axes, and h is the distance between the axes, m is the mass of rigid body. And we can write Ig, that is moment of inertia about center of gravity, as m k square. K is the radius of gyration. We can substitute this in equation 1, and then we will be getting t is equal to 2 pi into root of I. I is mk square plus mh square divided by mgh. M is common. This is now 2 pi into root of k square by h plus h divided by g. And this is the time period of compound bar pendulum. Remember, k is the radius of gyration, where Ig is equal to mk square, and h is the distance between center of suspension and the center of gravity. And this is the time period for compound pendulum.